Batteries. In this topic we will be studying the commonly used cells in the batteries which we do in our day-to-day life. Now we know cells are basically they are individual units, but when they are connected in series they form batteries. Now the cells of the batteries which we use in our day-to-day life, they can be of three types: primary cells, secondary cells, or the third category is of fuel cells. Let us first study the primary cells. These are the cells which cannot be recharged again. Their electrolytes once used gets decomposed and they cannot be regenerated back. So they cannot be recharged again. Now they are of two types. The dry cells, the one which we use in our radios and torches, in transistors, in our normal, we can say the normal toys, which are available in three sizes in the market, A, AA and AAA, these are called the dry cells. The second category is of mercury cells, the button cells which we use in wristwatches or in electronic devices, in calculators and digital diaries, etc. Let us see first the dry cell. Dry cell gives a constant voltage, it gives a voltage output of 1.25 to 1.5 volt. Now in this the vessel is made up of zinc and therefore which acts as an anode, and in the center we have a graphite rod around which we are having packed manganese dioxide with charcoal. The electrolyte is ammonium chloride along with certain small amount of zinc chloride. Now the reaction involved in this are that the anode is of zinc vessel. It gets oxidized to zinc ions and releases 2 electrons. Now these electrons, after passing through the circuit, they comes back to the cathode, where a manganese dioxide in the presence of ammonium ion accepts these electrons and get reduced from +4 state to +3 state and forms Mn2O3. The ammonium ion gets consumed in this and they gets converted to ammonia and water is formed in this. If we add these two reactions, electrons gets cancelled and this is what is the overall reaction is. Now the problem with this cell is this: it shows two types of problems. It shows potential drop. The voltage output keep on decreasing the moment you start using it. The reason is because the main charge carried between the cathode and the anode, which is the ammonium ion, its concentration starts decreasing, because as soon as you start using it, its concentration starts decreasing. So therefore the potential output is never constant, and that is why we cannot use these types of cells in the electronic devices, because they need constant voltage output. The second problem with this is that since water is produced in the reaction and the zinc vessel gets corroded by the continuous use of it, it might be if these cells are left out in the appliances, the electrolyte along with the water gets leaked out in the appliances and they can damage your appliances. So these are the two problems we faces normally, and that is why normally nowadays in the market we get dry cells which are having an outer, again a protective covering which protects them from the leakage, and that is why they are called leak-proof cells. So these are your dry cells. From here we actually got the basic idea that why these cells were showing the potential drop, because their main electrolyte was getting consumed in the reaction and it was not again being reformed or again actually being formed during the reaction. This was corrected in the mercury cell, button cell. Now let us see the mercury cell, the second type of the primary cell which we have, which gives a constant voltage output. See, mercury cells gives a constant voltage output of 1.35 volt, and their constant voltage comes out till all of the electrolyte in these cells gets consumed. Now these cells again are made up of the vessels of zinc. At the center we have a graphite rod which acts as a cathode, electrode, and the electrolyte mainly used is this, and the species which is getting reduced is the one which is actually mercury oxide. And the main electrolyte between cathode and the anode is the alkalis, either NaOH or KOH, and the main charge carrier are your OH minus ions. So the vessel is of zinc, the species which is getting reduced is mercury oxide, and the main electrolyte are your hydroxyl ions, OH minus ions. Now what happens at anode? The zinc vessel, in the zinc combines with the OH minus ions, gets oxidized to zinc oxide, forms water and releases 2 electrons. Now these electrons and from the circuit it enters into the cathode, where mercury oxide accepts these electrons in presence of this water formed, gets reduced to mercury and forms the OH minus ions back. So the number of OH ions consumed are equal to the number of OH minus ions which are formed, so they get cancelled. The water formed and water consumed are again same, and the electrons produced and electron consumed are again the same, they get cancelled. So the overall reaction comes out to be zinc reacting with mercury oxide, forming zinc oxide and mercury. What we find in this cell is that the main electrolyte OH minus ion, which is the main charge carrier in the cell, their concentration remains same. So that is why there is no potential drop problem, and the cell gives a constant voltage till all the mercury oxide gets converted to mercury. And that is why we can use these cells in our electronic devices like hearing aids, in digital diaries, in your wristwatches, etc. So this is the advantage of this one.